Let's therefore proceed to the fundamental discussion of the day. When we talk about electrochemistry, what really do we mean? Now, as earlier stated, electrochemistry is simply that branch of chemistry that looks at the link between chemical reactions and electricity. Now, talking about link, this link can be studied in two major ways. What are these ways? The link between chemistry and electricity can be studied from the point of view of chemical reactions that triggers the generation of electricity. And this branch of chemistry is referred to as the study of electrochemical cells. So electrochemical cells are cells that bring about the generation of electricity as a result of certain chemical reactions taking place. The second way in which the generation of electricity or the link between electricity and chemistry is studied is that aspect in which there are chemical reactions that need electricity to take place. That is to say, without the presence of electricity, these reactions don't take place. And such kind of reactions, or this branch of chemistry is referred to as electrolysis. So, these are the two major branches or links for which we are going to be discussing electrochemistry today. So with this in mind, let us proceed further to knowing what electrochemistry is. Now, it is worthy to note here that electricity comes into chemistry because certain materials permit the flow of electricity. Metals, for example, permit the flow of electricity because it possesses electrons. Metals possesses electrons, and these electrons are free to move from one point to another. So that is why they permit the flow of electricity through them, as electricity goes through these metallic objects. On the other hand, there are substances which are usually in their aqueous or molten states, which also permits the flow of electricity because they possess species that are called ions. And examples of these substances in molten or aqueous state is sodium chloride. For example, a solution of sodium chloride can permit the flow of electricity through it because of the presence of ions, which enables that process to occur. Now, electricity itself can be generated via frictional method or chemical method. So these are the methods that can bring about the generation of electricity. Now, talking about electricity being generated either by frictional method or chemical method, that will now lead us to this subtopic referred to as static and current electricity. What then is static electricity? When we talk about static electricity, it is that electricity that is generated through frictional contact. A good example of such kind of electricity is when we brush our hair with a plastic comb or vigorously let a pen to go through our hair, or we can also observe that when a glass rod is being wiped with a silk material. Sometimes also we can observe this when we are trying to, when we iron silk materials or trying to put on these silk clothes or remove them, right, to pull off our silk clothing. We observe this kind of tiny sparks that is usually generated around this silk material. So when we brush our hair or vigorously let a plastic comb go through our hair or a plastic pen go through the hair and we bring such material close to a piece of paper, we observe that the piece of paper gets attracted to the comb or the plastic pen. This is because the plastic pen or comb has actually acquired some electrical charge, which is referred to as static electricity. Why is it static? It is static because this electricity thus generated on the plastic matter does not leave the matter. It doesn't leave the comb or the pen. It stays around it. It stays on it because it cannot be transferred to the ground, for example, or to our body, because these materials are poor conductors. The plastic comb, the plastic pen are poor conductors. If the plastic comb or pen were to be a metallic one, then when this charge, this static charge is being generated around the comb, there is every possibility for it to be transferred to the ground, for example, or any other matter in contact with it. But because these plastic materials are not conductors, the charge thus generated around them remains around them. So that is why when we bring some pieces of paper close to the plastic comb or the plastic pen, it gets attracted to that pen. And that is actually what we refer to as static electricity. So we usually observe this happening also, as we have said before, when we try to pull off our silk clothing or even try to put them on, or sometimes when we iron the silk clothing, we observe this type of tiny spark that is generated around the material. So this is what we refer to as static electricity. So this is an example of what we're trying to talk about. As you can see displayed on the screen, we can see that when the comb goes through the hair, it actually acquires this electric charge. That is, electrons surround the comb as negative charges. And then when pieces of paper is brought close to the comb, we see that the paper gets attracted to the comb. And that is actually what we refer to as static electricity. So with that in mind, let us proceed away from static electricity. Let us talk about current electricity. So what then is current electricity? Current electricity consists simply of streams of fast moving negatively charged electrons through a conductor like wire, rod, for example. Why is it so? It is because when these streams of fast moving electrons passes through this conductor, a potential difference is usually created, and as this potential difference is created, it enables these fast moving electrons to keep moving and keep moving through the circuit. So this is actually why it is referred to as current electricity, because they move at the same speed, they move as a beam, and they move continuously. That is why it is referred to as current electricity. So still talking about current electricity, it is worthy to note here that some substances permit the flow of electricity either in their molten state or their aqueous state, as we have said before. Why is it so? It is because these substances possesses what is called ions. So the ions permit the flow of this electric current through them. What are these substances that can permit the flow of electricity through them in their molten or aqueous states? They are called electrolytes. We shall get to discuss more about electrolytes as we go deep in the class. Metals also permit the flow of electricity through them, but unlike the electrolytes, metals don't show any chemical kind of change when electricity passes through them, but they only allow electricity to pass through them, and the presence of electricity through them can be confirmed by the glowing of any electric bulb that is attached in this electric circuit. So when we have electric bulb, for example, attached or connected to the electric circuit, as electricity or the fast moving electrons flow through this rods or wire, we can confirm that current is flowing through the metallic conductor as the bulb glows. So that is actually a confirmation. But in terms of chemical changes, no chemical change actually is observed when electricity flows through these conductors. So just as we can see on the screen, and this is an example of an electric circuit which will bring about the flow of electrons, fast moving streams of electrons. And as these electrons flow through the circuit, it actually makes the bulb that is attached in the circuit or connected to the circuit to glow, and that is actually what is called current electricity. So with this, we make a difference between current electricity and static electricity. So as you can see, the fast moving electrons, as they move through the circuit, this is what we refer to as current electricity. Let's look at that flow again. You can see the bulb is lit, and of course when the disconnection is made, the bulb goes off. But once the connection is made again, electrons flow, and of course the bulb comes on again. So this is what we refer to as current electricity. So having seen current electricity, let us proceed to looking at more of the features of current electricity, and that will be talking about current electricity. Still, we have said earlier on that electricity can flow through some substances and it triggers reaction. So these substances that only takes effect in terms of chemical reaction when electricity passes through them are actually called electrolytes, and that kind of mechanism is called electrolysis. But on the other hand, there are certain chemical reactions that will take place and thus leads to the generation of electricity. This kind of reaction is actually referred to as electrochemical reactions, and the devices that bring about this kind of electrochemical reactions are simply electrochemical cells, just as we can see the picture displayed. It is an example of an electrochemical cell which is made up of copper rod and zinc rod dipped in their solutions, their aqueous solutions, solution of copper 2 sulfate and a solution of zinc sulfate. And of course, we have a connection between these two solutions. That connection is called the salt bridge connection, and it allows this flow of electrons, this current of electrons, so that electricity can be generated. Let us get to see how electrochemical cells can generate electricity. It does so by what we refer to as redox reaction, or simply oxidation reduction reaction. So as we can see displayed on the screen, this is an example of an oxidation reduction reaction. In an oxidation reduction reaction, we observe that one of these metals loses electrons, and once you lose electrons, you are said to actually undergo oxidation. So as one of them loses electrons, the other gains electron. The gain of electron is reduction process, while the loss of electron is oxidation process. As oxidation reduction reaction takes place, it leads to the generation of electricity, and this is actually how electricity is generated by electrochemical cells. As this reaction takes place in the cells, which we don't see physically, we see simply that it leads to the generation of electricity. So hence, the bulb will tend to come on. So in the case of the electrochemical cell as seen displayed on the screen, the zinc rod or zinc metal loses 2 electrons, and these 2 electrons is being received by the copper metal, and that process continues on and on, thus leading to the generation of electricity. Okay, so with that in mind and having understood vividly the difference now between static electricity and current electricity, we should proceed to discussing in depth what electrolysis is.